Thanks, Mike. That's awesome. So yeah, we're Snowplow. We're the co-founders of Snowplow, and we're here to talk to you today about open source game analytics powered by AWS. So I'm Alex. This is Yali. We co-founded Snowplow back about 5 years ago. So around the time that the original Minecraft was released. And Snowplow is an open source event data pipeline that's built on top of AWS. So it lets you collect very granular, rich event level data. And when we started, we just had a JavaScript SDK, but over the years, we've added lots more. So now from a kind of a games developer perspective, you've got C++, Android, Objective-C, Unity, Flash, Java, all that kind of stuff. And the Snowplow model has always been about a very kind of compartmentalized flow. So we collect your data, we validate your data, we add extra stuff to your data like geographical location, things like that. We model that data, and then we deliver it into different databases that you can use to then analyze it. So from an AWS perspective, we support Redshift, S3, Elasticsearch Service, things like that. So why did we create Snowplow back in the day? The reason was that we were just super excited about digital event data. So if you think about digital event data, what does it let you do? It really lets you capture any kind of user behavior, any kind of player behavior. You know, how people play, how people work, how people socialize, how people interact in all sorts of different environments. It just gives you, collecting that data in a very raw, very atomic way, just gives you endless possibilities to ask different questions, come up with different theories, work through that stuff. And back when we were creating it back 5 years ago, the big challenge we had was that there were a lot of different packaged solutions out there. So we kind of came from a web background, so we were very used to things like Google Analytics. And we just got very frustrated at the fact that we couldn't do the kinds of analyses, the kind of bespoke analyses that we wanted to do. So fast forward to today, a lot of companies build their own event data pipelines. A lot of game studios will build their own event data pipelines as they kind of develop, as they mature from indies into bigger companies. But if we as Snowplow can build a standard event data pipeline, that lets you guys focus on actually doing stuff with the data. So at this point, I'll hand over to Yali, my co-founder, for our call to arms.
So yeah, to pick up from where Alex left off, we as Snowplow have worked with a ton of different companies in a ton of different industries, and it's very interesting to think about the different games companies we've worked with and compare them with some of those other, traditional publishers and retailers and financial services companies. And what we found is that really games companies as a whole are incredibly analytically sophisticated. They tend to invest in their own event data technology, their own event data pipelines quite early on, even as indies. And if we think about that and why it is that games companies are so sophisticated analytically, I think there are two real drivers that we see. So one is analytics is very specific to each game. Two different games are going to have two totally different event data sets. And the kind of questions that you're going to ask of those data sets are going to be very different. But secondly, and perhaps more importantly, data sophistication is a key kind of competitive driver. If you really are on top of your data, if you're on top of your analytics, you can acquire users and monetize them more effectively than your competitors, and you can use that data to evolve your game very rapidly. So it isn't really a surprise that when you look at the larger game studios, they have very large data teams, data engineers, scientists, and analysts, and very significant infrastructure. And when I look at what we're doing at Snowplow, we're really trying to enable smaller studios and indie developers to get started on that journey, get started with that sophisticated analytical setup earlier on in their journey. So if there's one message that I hope you all take out of this talk, it's that if you want to start on that journey, if you want to start really doing analytics right, you don't have to start building this stuff from scratch. You can take our open source pipeline, which is built on all these lovely AWS services, and we're going to go into how that pipeline works and how those underlying AWS services work and what different people use that technology to do in gaming. You can deploy that in your own AWS account. and you can focus your effort on using that data to make a difference and really build out your game rather than building the pipe. So building high-quality event data pipelines is surprisingly hard, and it took us by surprise. I mean, we've been building them now for more than 5 years. So it's surprisingly easy to come up with a solution that gets you kind of 80-90% of the way there, and it's becoming easier and easier as the cloud data, big data service set gets more and more mature. But really the things that distinguish good quality data pipelines from less good data pipeline solutions are a focus on data quality. So when data gets processed successfully, that's great. But how do you spot those occasions when it doesn't? Because sometimes that data that fails to make it through, that's the difference between answering a question right and answering a question wrong. Schema evolution is another really, really important kind of analytical problem that we find people don't spend enough time thinking about. So I'll come back to that a bit later on in this talk, but your game is going to evolve, your game and your games. The questions you're going to want to ask of the data and the answers you're going to want to develop on through your data analysis are going to change. And so your event data pipeline is going to need to evolve, and how you manage that becomes important. Alex mentioned data enrichment. Often when we're tracking events that occur, be they in the game or in the marketing channels that you're acquiring users or engaging your users, often there are things that you want to know about that event that aren't available at the point that you collect the data. So having a framework that lets you call out and pull in that additional data and attach it to the event data is really important. And then something that we're spending more and more time at Snowplow thinking about is something we call event data modeling. So our users typically have this very, very rich, very, very granular, very, very detailed data set that describes everything that's happened, every action that the player has taken in their game. And that's actually a very difficult data set to consume and ask questions of. It's a fine data set if all we want to do is count the number of events that have occurred and group them and compare them between cohorts. But often we're interested in the sequence of events. We're interested in specific passages of play. And actually taking that data and aggregating it up to really understand what's going on a per level or per game or particular part of the level is quite an analytically complicated operation. And so we're starting to think about building out tooling to make that sort of analysis easier. So just very quickly, today Snowplow is used by a bunch of game studios, and it's great to see Code Combat guys here. I think Spacescape Games, Peak and Memrise, hopefully all their representatives here at GDC. But our view is also colored by the work we do with companies in other industries and publishing, in two-sided marketplaces, in financial services, and lots of different sectors that we work. But we've been very lucky. We've worked with games companies right since our inception, and a lot of what we've worked and a lot of our thinking has been influenced by those companies that we worked with. So it's actually the early games companies that we worked with that taught us about the importance of flexible data schemas that evolve. Games companies also taught us about event grammars, so how you structure your event data. And what we realized is that a lot of the data points that you're tracking when you're tracking an event aren't specific to the event you're tracking. They're metadata about the level or the game or the player that's actually common across different event types. And coming out with a structured way of letting our users define those data points and track them across different events and then compute on those events is something we've spent a ton of time thinking about. And I've already mentioned evolving data models. Again, that thinking was born out of a lot of our early work with game studios that wanted to understand the sequences of play in the game. So if we take a step back and we think about games analytics, it encompasses a huge amount. So product analytics in terms of using data to actually improve the game itself. Customer acquisition analytics, which is sort of a really, really, really key element, especially for games in the freemium sector. Game health analytics, totally different branch of game analytics, but just being able to understand what people are doing in your game right now and checking that the game is healthy and working as it's supposed to be. We're seeing more and more instances of data-driven applications within the game. So actual data about play data then being fed back to somehow change the game experience in one way or the other. And of course, these are just the broad buckets of analytical question that we see asked across our user base of games companies. There are plenty of specific questions that are specific to specific games and specific game studios. So if we think about the technology that we're gonna employ on AWS to deliver these types of analytics, we very broadly distinguish between two types of analytics, where both those types of analytics require different kinds of technical infrastructure to deliver them. So on the left-hand side, we've got analytics on read. So analytics on read applications are applications where we want to maximize flexibility to query the data in as many different ways as we want. So we're deciding on the question we want to ask, and we decide on the query we want to run on the data as late as possible, at the point of query, in fact. And so we're prioritizing that flexibility over query latency. We're only going to decide, we're going to come to the data and we're going to ask it any question we want, but we've got to accept that the cost of that is that the query might take a few seconds, a few minutes, maybe a few hours to return a result. And maybe product analytics is a good example of analytics on read. And it's worth contrasting that with analytics on write use cases where we really want to prioritize low latency. So we want very, very fast results. We want to know exactly what's happening in seconds from the moment it happened. But we know, hopefully, in advance what it is we need to know. And so in these situations, we decide in advance how the data will be queried. And we don't have the flexibility then to change it necessarily after the fact. And probably the most obvious example of an analytics on write application is game health monitoring. So the types of technical infrastructure to deliver both of these types of analytical approaches are different, and we can actually meet both use cases using a Lambda architecture. So hopefully this diagram is reasonably clear. It's a schematic of the Snowplow pipeline as it runs on AWS, and I'll just step you through how it works and the different underlying AWS services that we're using under the hood. So what you can't see on this diagram are the different trackers, the different SDKs that Alex mentioned that you'd actually integrate in your application, either server-side or client-side or both, to collect those events. But those trackers, those SDKs are out there, and they're blitting the event-level data into Snowplow over HTTP, and that data is hitting the stream collector, which is effectively an HTTP endpoint. So a group of EC2 instances sat behind an elastic load balancer, and that data is then being written as it's hitting the collector out to a Kinesis raw stream. So Kinesis is a distributed logging technology that is very, very powerful when you want to build low latency, big data processing, real-time applications. So the data is streamed out to that Kinesis raw event stream. And then we have two different processes that are consuming the data independently off that stream. So on the real-time side, which is really the analytics on write side, on the left-hand side of the diagram, we've got an application we call Kinesis Enrich that's reading those raw requests off the event stream. And that application is doing a couple of things. The first thing it's doing is it's validating the data. So you as a Snowplow user, you define your events, you define your entities, and then you send the data into Snowplow as self-describing JSONs, which are JSONs with a reference to the schemas that describe what the JSON is and what field it should have. And the first thing we do is validate that the data is maps to the schemas. And assuming it does, we use those schemas to structure the data and then enrich it. And we write the data out to the good event stream. If anything has gone wrong with that process, if the schema hasn't validated or hasn't been successfully processed, that gets written out to the bad stream, and we can actually monitor for bad data and then hopefully fix whatever the upstream issue is that caused that to minimize the impact of bad data. So data quality is something I mentioned earlier, and this is one of the ways we manage data quality. But once that good data is written out to the Kinesis stream, that data is then available for our analytics on write applications. So we'll typically sync it to Elasticsearch in real time, so the data can be kind of poked at and queried. But really what that data is there for is that you can put different applications live on it, and those applications can read the data as it's streaming in. And I'll give an example of some of those in a bit. On the right-hand side of the diagram, we've got the part of the data pipeline that is about delivering the analytics on read, those analytics on read applications. So we've got an application called Kinesis S3 that's reading the raw requests off Kinesis and syncing them to S3 for posterity. So then your data's safe and it's stored. And then we run it's actually the same enrichment process that is run in Kinesis, but we can run that in a batch mode on EMR. It uses Spark under the hood. So again, that validation, that enrichment piece. But once that data's been through that validation enrichment, we write it back to S3 and we load it into Redshift. So what that means is our users have their complete event level data set in S3, where it's accessible for querying in Spark on EMR or Athena. And that data is also in Redshift, a beautiful scalable columnar database, so you can put different visualization tools on top of it, surface that data to your product team, surface that data to your marketing team, sort of empower your team to go into that data and use it to answer real questions. So that's the technical infrastructure. Let's dive into some examples of how it's used. First of all, to do analytics on read, and then second of all, to do analytics on write. So A/B testing is I think probably the most creative element in analytics. If I look at what our users are doing around A/B testing, you really see you see a whole spectrum of tests that are being run. On the one hand, very, very specific. Does the red button perform better than the blue button? What drives the highest click-through rate? All the way through to very, very fundamental A/B tests, trying to change the underlying game dynamic to see which game is more playable, which variation will drive better 2, 4, 7-day retention. So A/B testing is kind of this incredible thing, because really the possibilities in terms of what sorts of experiments you can run are really only limited by your imagination. And then depending on the type of experiment that you want to run, what metric you're going to want to look at to decide whether the A/B test was a success or not are gonna vary. So there's really no limit to the experiments you can run, and there's no limit to the number of different metrics that you might be interested in computing to determine if your A/B test was successful. And I was thinking back to the talk that Mike gave this morning when he was talking about all the different emotional dynamics that can be built into a game to make it more playable. Those are all things that you can A/B test before launching. So really, if you take A/B testing seriously, and all our games clients really do, then it's essential that we enable them to make tracking those experiments easy, and that they have that full flexibility to run whatever experiment they want. So we see amongst our users product managers that define multiple different, they might be doing 10 or 20 different experiments in a very short, in a week or a 2-week period. They've defined those A/B tests in advance. They've defined the different KPI and success thresholds in advance. And they've got a very well-documented history of all the different tests that have been run and all the different learnings, so that they're constantly kind of evolving their understanding of what drives gameplay. And in terms of the technology, because our users have this very detailed event stream that defines exactly what the players have done, the only extra thing we need to know when we run an A/B test is actually what test group, whether the user was in a test group, and if so, what variation of the test they were shown. And then hopefully our event tracking is complete enough that we know everything else that happens in the game, and we can compute after the fact whatever metric we want, whatever KPI, to understand whether the impact of the test was as predicted or not, whether it hit the threshold. So having that complete event stream either in Redshift or in S3, and being able to run any of those queries so we can compute any of those metrics on the test group versus the control group, are really, really key. A second example, slightly different, around level optimization analytics. So this is an example from one of our recent users, Code Combat, who are in the audience, comparing a bunch of different metrics about how users engage with different levels in the game. So this is an example of event data modeling that I talked about earlier. So you have that full event stream, and then on that event stream, you compute more and more different metrics to understand different aspects of how a player has engaged with the different levels in the game. And what we expect to happen over time is that the number of these measures will increase. The number of columns in this table will just grow and grow as that understanding deepens. And in terms of the process that enables this, users will slowly think of more and more different measures to capture different aspects of the user's gameplay. And that data modeling process, which might be as simple as a set of SQL statements in Redshift or a set of kind of a Spark notebook on the data in S3, that will just be built out to compute more and more metrics. And as it's built out, those SQL statements, those Spark jobs can be run over the full historical data set, so we can go back in time and apply those new measures to understand new aspects of play against the full history of data that has been collected. So really the wonderful thing about building Snowplow on top of AWS is that AWS is constantly giving us a bigger and bigger toolkit for doing analytics on read, and hopefully you've got a sense of how many of those different tools we've been using at Snowplow. So EMR has been really, really big for us, and all the work that the EMR team have done to put Spark in and make Spark work better has been great, Spark and Flink. Athena was launched just last December and is a very popular tool amongst our users, especially with larger data sets who don't necessarily want to load those full data sets into Redshift for cost reasons, to keep those data sets in S3 and flexibly run SQL statements against them in S3 using Athena. We've been using Redshift since it was launched, and it's still the primary way that marketing teams and product development teams interface with the event data that our platform collects. An Elasticsearch Service is something that a lot of our users are using, especially to keep track of the event data as it's streaming in real time. So if that's analytics on read, let's have a think about the other side of the equation, those analytics on write apps where we're prioritizing low latency over query flexibility. So one example where we'd want to have an analytics on write application is if we want to surface particular cuts, specific slices or aggregates of the play data back in the game. So then this is another example from our friends at Code Combat. Let's see if this works. So what you can see here is a map of the different levels in the game, and an actual visualization of the number of players per level, and where you see the kind of plasma cloud molecules moving between one level and another. Those are players playing the game right now, moving between one level and the other. So yeah, this is something the Code Combat team has developed, and we hope to see in the live game quite soon. And it's just one example of how you might want to surface play data in the game, but you can imagine there are kind of countless ways of doing it. So in terms of of doing that, the underlying tool set that we're using is actually totally different. And again, AWS provides some very, very powerful tools for doing this. So in that specific example that I just showed you, what's actually going on is we have the full event stream coming in Kinesis. And whenever a player is active in a level and does something in that level, that's captured as a line of data in a JSON format. So we know what event occurred, what level it was in, and who the user was that performed that action. We then have a Lambda application that is consuming that event stream, and it's looking through the event stream for any event which indicates that a particular player is in a particular level, and it says, hey, player U is in level L, so I'm going to write off to a player state table in DynamoDB and say, right now I know that this player is active in this level. And you can imagine as a player's moving through a level, many, many events are occurring, and each time the Lambda's pinging off to Dynamo to say, hey, this player is still in this level, this player is still in this level, this player is still in this level, and all those upserts are being made in Dynamo. But at a certain point, the player's going to move to another level, and at that point, the player state table, the record for that user is going to change. So we're going to the line of data is going to say this player is now in this level rather than the previous level. And what we're using under the hood is this beautiful feature in Dynamo called Dynamo Streams, where any time a change is made to a Dynamo table, that is emitted as an event. And that event is then consumed by the second Lambda in the diagram. So that Lambda looks, and it can basically see any change in player state. So it can see if a player's left a level, it can see if a player's entered a level, and it can see if both of those have happened simultaneously. And wherever it sees that, it then pings off to it then updates a level state table in Dynamo to say, hey, because the player left this level, let's reduce the count of players in that level by 1. The player entered this level, let's increase the player count by 1. So what's interesting, I don't want to go into too much detail in how this application works, but taking a kind of a high-level view, what's interesting is that each of these different components was very, very simple to write. The Lambdas are very, very simple. The logic in them is very, very easy to diligence. And the player state and the level state tables in Dynamo are very, very simple. But strung together in this kind of architecture, we're actually elegantly handling the computation of a pretty complicated metric, which is account distinct in real time, which I think is pretty cool. To look at a totally different example of an analytics on Write app, and this should be very interesting to anyone in the freemium space. Tiered support is a really interesting problem. If you've got a whole bunch of users, and some of them are whales that are spending enormous sums of money in your app, and some of them are not spending anything, you need to be able to quickly identify which one of those 2 or 3 different user types they are when they lodge a support query, because you're going to want to provide a totally different level of service for those whales versus those free users. And again, delivering that can be done using a very, very similar tool set to the one described before. So again, you've got your Kinesis event stream, but this time we're interested in a different subset of events. This time we're interested in those events that indicate how valuable a player is, which will often be transactional events. So we have those events coming in. We have a Lambda that reads them off and computes the player's lifetime value, and that might be a sophisticated calculation. It might be a very, very simple calculation. But either way, the results of that calculation are then written to a player state table in DynamoDB, and that can be exposed as an API to any service we want using API Gateway. So in this specific example, we've got Zendesk as the platform that's used to triage the different support tickets, and Zendesk can ping off to the API to say, hey, I've just had a ticket in from player XYZ. What level of support should we be looking to when we answer this person's ticket? Is it a concierge level service, or is it a much more basic service? So in the same way that AWS provides a rich and growing toolkit for analytics on read, it also provides a rich and growing toolkit for analytics on write. So EMR is part of that toolkit, and you can run Spark streaming on EMR. We've also made extensive use of the Kinesis client library. But perhaps the most exciting things from AWS in terms of real-time data processing are their serverless event processing solutions. So I've talked a lot about AWS Lambda, this service that lets you just define functions that can run on streams, and then AWS takes all the hassle out of instrumenting them and scaling them up and down with changes to your event volumes. A very, very powerful service. We've made a lot of use of that at Snowplow. And then another service that a lot of our users are very interested in is Kinesis Analytics, which lets you, as an end user, query the data in stream using SQL. And that's very, very interesting for our users, because a lot of them are analysts who have a lot of SQL expertise, but a lot less comfortable about writing processing jobs in things like Python or JavaScript. So I'm going to hand back to Alex, who's going to talk about some design considerations for game analytics.
Thanks, Yali. So in the last section, Yali really dove into some very concrete how-tos for analytics, game analytics, making use of AWS services. In this section, I just want to talk about a few big themes around designing your game analytics. And these are things that we've seen over the years working with game studios using Snowplow and seeing those game studios evolve and grow over time. So the first consideration I want to stress is keep your analytics stack independent from your game stack. So you might have been hearing about the player state table, things like that, and thinking, well, I already have one of those in my game server. But we really think that you want to be keeping that analytics stack separate. So reasons for doing this. We want you to evolve the game and the analytics independently. As your team gets bigger, you're going to have different people focusing and prioritizing those different things. You want to reduce fragility by not having the analytics requirements bleeding back into the game. You also want to use the best of breed components for each. So, you might have a very sophisticated back-end game server. You might have something written in C++ or Erlang or Akka, something like that. But actually, the best of breed tools that you're using in your game, they probably don't apply so much in the event analytics space. So, many of the tools that Yali talked you through, we've really kind of optimized those and identified those as being great for event analytics with games. And then I think the other thing just to flag up is the very different scale requirements. So your game volumes will be of a certain size, and they'll obviously scale with player volumes. But actually, what you'll find, and we've seen this with games using Snowplow over the years, is that actually your event volumes from your games just rapidly kind of blow up to very huge proportions. And of course, it's cumulative. You're just constantly adding to that. And you tend to be retaining that as well because you want to be able to do those cool analytics on read behaviors. So the big theme here is really keeping that analytics stack separate from your game stack. This is really a point around that kind of dichotomy between the analytics on read and the analytics on write that Yali talked you through. So one of the things you're probably thinking as well, do I do both? Which one comes first? How do I approach this? And our kind of recommendation here is really to start with your analytics on read and then move into analytics on write as you kind of build confidence. So you really want to be starting by collecting everything, collecting that whole event stream, and then really you can then apply analytics on read to that. So an example we have here is figuring out how to optimize customer acquisition best. Where the end game is you want to be setting bid prices that are tailored to the kinds of users you're acquiring. So the way you typically do this is you're collecting all your events in analytics on read way. You're developing that model offline, you're testing it, you're training it on historical data, and then as you build confidence in that, you're then able to take the output of that model and then really ship it to production, where shipping it to production could mean putting it into a Spark streaming job or writing some Lambda functions. So this is kind of a general process, and it's tended to work quite well for game studios we've been working with. This is a really important point. So Yali talked earlier around a lot of the stuff that we've seen over the years with game studios, and it's really this idea that change is constant. And even within the lifetime of a single game, change is inevitable. The game will evolve, and your data team, your analysts, your scientists, your user acquisition people, even management, they're all going to want to start asking new questions of that game. So it's really important, even if you're a super small indie, even if you don't have someone who gets to spend a lot of their time thinking about analytics, it's really important even at that level to start establishing how you're going to handle this stuff as you grow. So how are you going to handle changes to the events and the schemas? So as you change the in-game entities, and how are you going to handle redefining the event modeling that you're doing as those questions change? So there's a lot around technology, but there's also a lot around kind of the organization that you put in place as you grow. So those are three big kind of design considerations. We've kind of seen those working with game studios at Snowplow, but yeah, we think they apply pretty broadly to game analytics. So to come back to our original kind of call to arms, we really believe strongly at Snowplow that you should standardize on your event data pipeline. We don't think you should reinvent the wheel. We think you should use our open source stack. It's been around for a long time. We've been developing it all that time, and deploy it into your AWS account. As and when you get the capability to have data engineers and an internal team to really build this stuff out, let those guys develop analyses and do event data modeling that's specific to your game, not to kind of reinvent the wheel and rebuild the underlying pipeline. So to learn more about Snowplow, please check out our website. And that GitHub repo is the core of the open source code. So all the Snowplow code base is Apache 2 licensed, very liberally licensed, and you can use it in your projects. So thank you. So as per all the previous sessions, there's a survey to fill out. You can go to bit.ly dev day survey. The capital D and S are important. So please do fill that out. And Yali and I will be outside to take questions after this session. And I think that's everything.